Have you ever just stopped and looked around? I mean, really looked at the screen you're on right now, the chair you're in, even the air you're breathing, and wondered, what is all this stuff really? It's got to be one of the biggest questions you can ask.
Well, in science, we've got a word for all that stuff. We just call it matter. It's simple, right? From these huge trees to that little soccer ball, if it has some weight to it and it takes up room, then yep, it's matter. It's basically the physical ingredient list for our entire universe.
But, okay, giving it a name is one thing. That doesn't really answer the question, does it? If we could zoom in, like way, way past what our eyes can see, what would we find? What are the actual fundamental building blocks of everything?
All right, let's get into it. To even begin to understand the world, scientists start by sorting everything. All matter gets split into two big main buckets. And this first split, well, it's the most important one to get. So, let's just make it official. The textbook definition of matter is anything that has mass and occupies space. Simple enough, right? Well, that's kind of where the simplicity ends and the real fun begins. And here it is, that first big split. On one side, you've got pure substances. Think of something like pure gold or totally pure water. Every single tiny particle is exactly the same. But on the other side, we have mixtures. This is where you just physically blend things together, but they don't chemically change. And honestly, most of the things you run into every single day are mixtures.
Okay, so let's stick with that mixtures category for a minute, because it turns out not all mixtures are the same. It really just comes down to one simple thing. How well are the ingredients mixed together?
And this is the perfect way to picture it. Over on the left, you've got a salad. It's a mixture, for sure, but you can see all the different bits, right? The sprouts, the tomatoes, you can pick them out. Now look at the right. That's sugar water. Once you stir it up, the sugar seems to disappear. The whole thing looks exactly the same from top to bottom. It's perfectly blended.
All right, so let's slap the official science names on these. The salad is what we call a heterogeneous mixture. Hetero just means different, because, you can see the different parts. The sugar water is a homogeneous mixture, and homo means same, because it looks the same all the way through. See? Pretty straightforward.
And get this, the air you're breathing right now is a perfect example of a homogeneous mixture. It's mostly nitrogen and oxygen gas, with a few other things thrown in. They're all just kind of hanging out together in the same space, but they're not chemically connected. You can't just look at the air and go, oh, there's some oxygen over there. Okay, so we've got a handle on mixtures. Now, let's rewind and jump back to that other side of the chart, pure substances. This is where things get really fundamental. This is where we find the true building blocks of our world.
Now, this is so cool. We think of water as being pretty pure, right? Well, it turns out you can break it down even more. In this experiment, they're zapping water with electricity, and it's literally splitting it apart into two totally different things, hydrogen gas and oxygen gas. So pure has levels.
And that brings us to the absolute bedrock of reality, an element. An element is a pure substance that's made of only one kind of atom. Think gold or iron or oxygen. You can't use a chemical reaction to break them down into anything simpler. They are the base ingredients in the universe's cookbook. You can't get any more fundamental than that.
So, what happens when you start using those ingredients? You get a compound. This is also a pure substance, but it's what you get when different elements lock together through chemical bonds. And that phrase, chemically bonded, is everything. This isn't just mixing them in a bowl. It's a reaction that creates a brand new substance with its own unique properties.
This table sums it all up beautifully. Elements, one type of atom, can't be broken down. Compounds, more than one type of atom, and you can break them down, just like we saw with water. But here's the coolest part. The properties of a compound are totally different from the elements that make it up.
So let's actually look at this. This is what an element looks like on the smallest scale. This is oxygen. See how every single particle is identical? It's all just oxygen through and through. Now compare that to this. Here's a compound, water. You can clearly see there are different kinds of atoms, the big oxygen and the two little hydrogens, and they're all locked together to make one single thing, a water molecule. Totally different structure.
And this is the magic rule for compounds. The recipe is strict. Water is always H2O. 2 hydrogen atoms, 1 oxygen atom. It's never H3O, it's never HO. If you mess with that recipe, you don't have water anymore. You have something else entirely. That fixed ratio is what makes a compound a compound. So we've gone through all these categories and definitions, but why? Why does any of this matter outside of a chemistry class? Well, it turns out knowing the difference is how we build, well, pretty much everything in the modern world.
This is where the rubber meets the road. Understanding how to mix things versus how to chemically bond them. That is how we design life-saving medicines. It's how we create super strong new materials. It's how we invent the technology that will shape our future.
Think about alloys. That stainless steel fork in your kitchen drawer, it isn't just one element. It's a very specific, homogeneous mixture of iron, chromium, and other stuff. And by mixing them in just the right way, we get a material that's super strong and doesn't rust. It's way better than any of the ingredients by themselves. We've literally become master mixers. And then, on the flip side, just look at the unbelievable power locked inside a single element. This is graphene. It is one of the lightest, strongest materials ever found. And you know what it's made of? Just carbon. That's it. The same stuff that's in your pencil lead, just arranged in a different way. That's a revolution from just one element. So you see, from a simple salad to a material that could change the world, it all comes back to understanding these basic differences: elements, compounds, and mixtures. We've figured out the basic recipe of the universe. So the only real question left is, now that we know what the world is made of, what are we going to build with it next?